Good morning, class. We are looking at Chapter 8, Further Applications of Trigonometric Functions, Section 8.1, the Law of Sine. All right. In this chapter, we're going to look at the law of sine, the law of cosine, polar coordinates, equations, and graphs, polar form of complex numbers, the complex plane, De Moivre's theorem, vectors. The objectives for the section. Solve SAA. S stands for side, A stands for angle. So side, angle. For ASA, solve SSA, solve applied problems. Again, reminding everyone of what we have seen many times before, fundamental identities. Unit circle x squared plus y squared equals 1. Fundamental identities include Pythagorean identities such as sine squared plus cosine squared equals 1, quotient identities such as tan theta equals sine over cosine, and reciprocal identities such as cosecant is 1 over sine. Periodic functions, all trigonometric functions are periodic with a period of 2 pi. Except tangent and therefore cotangent pi. All trigonometric functions are odd functions except cosine and therefore secant. In a case of a right triangle, a squared plus b squared equals c squared, and of course a plus b, that's up to 90 degrees. The sum and difference formula such as sine of alpha plus beta is sine alpha cosine beta plus cosine alpha sine beta, and the rest of them. They give rise to double angle formulas. For example, here, change the beta to alpha. It gives you sine of 2 alpha, which is 2 sine alpha cosine alpha. Over here, change this beta to alpha, gives you cosine of 2 alpha. And there are 3 different ways of writing that. So one of them, for example, cosine 2 alpha is 1 minus 2 sine squared alpha. If you solve for sine squared, you get sine squared of alpha 1 minus cosine 2 alpha over 2. If you cut this in half, this becomes alpha over 2, this becomes alpha. From here, we can solve for cosine squared alpha, the same thing, cut it in half, and tangent is the ratio of sine to cosine. Now, these are all squared. What happens if you want sine of alpha over 2? You need a plus minus square root, and you figure out the sign based on the quadrant it belongs to. And we briefly covered product to sum and sum to product formulas. Now, the right triangle trigonometry application, we went over the concept, and here's the synopsis of that. If you have a right triangle, this is vertex A, B, C, A squared plus B squared equals C squared, A plus B equals 90 degrees. And if you look at this angle, okay, for B for now, the opposite is this side, B lowercase b. By the way, the vertex, the opposite is lowercase, and it's the side A lowercase a, B lowercase b, and this is C. And so with that being the case, adjacent to B is this side, and opposite to that is this side. So sine is opposite over hypotenuse. So sine of a B would be B over C. Cosine would be A over C. Tangent would be B, the opposite over the adjacent, B over A, or just the ratio of these two. The rest of them are reciprocals. Definition. Angle of elevation is the angle formed by the line of sight and the horizontal plane for an object above the horizontal. So basically, you look up, this angle is the angle of elevation. Angle of depression is the angle formed by the line of sight and the horizontal plane for an object below the horizontal. When you look down, this angle is the angle of depression. So you compare it to the horizontal line or plane in there. Since a bearing is used to represent the direction of one point relative to another. Method 1. The directional bearing of a point is the number of degrees in the angle measured in a clockwise direction from north vertical line to the line joining the center of the compass with the point. Method 2, direction or bearing of a point O to a point P equals the acute angle theta between the ray OP and the vertical line through O, the north-south line. In other words, method 1 says just figure out the north side and just mention the angle. So for example, this one would be 65 degrees. That's all you say, 65 degrees. This one, 300 degrees. And remember, clockwise is going this way, right? Method 2 says you compare it to either to north or south, the one that is closest. For example, P1, we're going to say north first, then the angle, which is 30 degrees, and the side, which is east. Whereas P3, it is still north, 70 degrees, but this time west. If I want P2, now I'm going to say south. The angle is 50 degrees, and it's on the left side, west. What about this one for P4? Again, this is closest to the south, not the north, because the angle must be between 0 and 90 degrees. So south, we are going 20 degrees to the right. That makes it east. So south, 20 degrees east. That's how you go with this second method. Again, with the first method, just the angle. For example, P4 would be this angle. For P4 would be this angle. And what is this angle? Subtract 20 degrees from 180, so it makes it 160. That's how you mention that. All right. 8.1, the law of sines, solving oblique triangles. What do we mean by those? None of the angles is a right angle. So what do we have here? All of these are less than 90 degrees. All angles are acute. So this one, each angle is between 0 and 90 degrees. In this one, only one of them can be obtuse. Obtuse means larger than 90, between 90 and 180. The other two must be small and must be acute. The sine law applies, and again, remember, here's vertex A, opposite that is side A. Here's vertex B, opposite side is B. Here's vertex C, opposite side is lowercase c. The sine law says sine A over A equals sine B over B equals sine C over C. And of course, all the interior angles, A plus B plus C, must be equal to 180 degrees. We will look at the proof later. So that's the sine law, or the law of sines, however you want to call that. All right. Cases, the law of sine, the cases of solving oblique triangles, none of the angles is a right angle. Case 1, ASA, angle, psi, angle. Side, angle, angle. In both cases, we have two angles and one side. In this case, the side is between the two angles. In this case, the side is opposite one of the angles. Case number 2, SSA, we have two sides and an angle. This is SAS, side angle side. The difference between these two is that this is called the included angle, angle between the two sides. SSS. We have all sides. So these are different cases of an oblique triangle that we want to solve. Case 1. ASA, SAA. ASA angle, side angle, and SAA side angle side. One side and two angles results in one unique solution and one unique triangle. So we have an answer, a unique answer, one answer. We will look at all of these examples later. Case number 2, solving oblique triangles. Case number 2, we have side angle. SSA, side angle, two sides and an angle opposite one of them. This angle is opposite one side. Results in several different situations and solutions to occur. Consequently, SSA is referred to as the ambiguous case, everybody. So, if A is acute and lower ka equals h, there is one triangle. In fact, it's a right triangle. If A is acute and A is larger than B, larger than H, one triangle exists. If A is oblique and A is larger than B, one triangle exists. If this is acute, if A is acute and A is less than H, it will never hit the next side. Therefore, no triangle exists. If A is obtuse and A is less than or equal to B, no triangle exists. The reason is very simple. The larger the angle, the larger the side opposite that. So if there is an obtuse angle, this must be the largest angle. This must be the largest side. In this situation, H is, on the one hand, is less than A, and A, on the other hand, is less than B. So A has a value between H and B. Since A is larger than H, a triangle is created. But since A is smaller than B, it can swing to the left of H and create a second triangle. So it can create this large picture, or it can create this one. Okay, there are two different possibilities. One is this entire triangle, A, B, C. You see that one is this smaller one. That's why it's called the oblique. That's why it's called the ambiguous case. Solving oblique triangle, case number 3. 3, SAS, side, angle, side. Two sides and the included angle. So the angle is in between. Results in one unique triangle. If the two sides are given on an angle, just any side will do the job as long as you connect it. Solving oblique triangles, case number 4. Side, side, side. 3 sides results in one unique solution and one unique triangle. As long as one side is smaller than the sum of the other 2 sides and it requires the next section, cosine law. The theorem that you probably remember is that each side, in order for them to be connected, one side has to be less than the sum of the other 2. Assume one side is equal to the sum of the other 2. So it covers the 2, but it doesn't cover any shape, any triangular shape. That's the idea. So the law of sines, or the sine law, is that sine of one angle to the opposite side is equal to sine of another angle to its opposite side. And in general, sine A over A equals sine B over B equals sine C over C. And we are going to prove that. So this is the triangle ABC. Opposite vertex A is lowercase a, opposite B is B, and so on and so forth. And this is the height, the altitude. You drop a perpendicular. So this is a 90-degree angle. So this angle specifically. So let's look at this angle B. And sine is the opposite H over the hypotenuse C. So sine of this angle is H over C. And we are looking at this one, okay, everybody? Therefore, the cross product, H is the product of these two. Again, everybody's fine with the cross product. H is C sine B. Now we look at this angle. And this triangle. Sine of C is H over the hypotenuse is B in this case, which makes H the product of these two, B sine C. So if they are both H, they must be identical. And so divide both sides by BC. Divide by BC. So what happens? Sine B over B equals sine C over C. This part. Let us repeat the same process with the altitude drawn from point B. Now, over here from A, we dropped a perpendicular. Now we drop a perpendicular this way, right? And we look at this angle, A, and let's look at this. Sine of A is the opposite, which is H, over the hypotenuse, which is C, and H is the product of these two. Now let's look at this angle. In this triangle, sine of this is the opposite H over the hypotenuse. And remember, hypotenuse is opposite the 90-degree angle. So over A and H is the product of these two pieces. Same thing we did here. We put these two equal. And now over here, we divide by BC. Over here, we're going to divide by AC. And sine A over A equals sine C over C. And I hope you see that if you put number 1 and number 2 together, because they both have a common equality of sine C over C, we end up with sine law, which indicates sine A over A equals sine B over B over equals sine C over C. Normally we write it in this format. If you write the reciprocals work too, but this is normally used. Now using sine law to solve SAA, side angle, triangle, solve the triangle A equals 40 degrees, B is 60 degrees, and A is 4. By the way, they may or may not give you the triangle. You should make something up, and even if not to scale, then you can fix it after you're done. Okay, that will help if you want to figure out what's going on. So for now, let me see what's going on here. So this is, since this is lowercase b, this must be capital B. Okay, of course this is capital C, it says so, and this is capital A. Okay, so this is lowercase a. We have lowercase b, lowercase c, and now let's find the rest of it. All right, the first thing, we have two angles. The third one just is add this up, subtract it from 180. They have to add up to 180. So that part is very simple. So the answer is we have the third angle, 80 degrees. So we have all the angles. Now we want all the sides. We have one of them. So since we have this one, we are going to go with sine A over A, right? We have these two, right? Sine A over A equals, doesn't matter which one, this one or this one. So sine B over B. Replace this with 40 degrees, lowercase a with 4, B with 60 degrees. Now, there is a cross product. I'll show you once, but you really should recognize B is the product of these two divided by this. So if we were to show this, is it different? We would say this, that means 4 sine of 60 degrees equals this, means B sine of 40 degrees, which means B is 4 sine 60 over sine 40. So we should recognize that. At this point, you put it into a calculator. So I'll show you. So we put 4 sine 60 divided by sine 40, it gives you this number. And if you want to stop here, you get 5.39. Whenever you do the rounding, you have to pay attention to what they ask you. If they don't ask for rounding, carry as many decimals. If you are rounding, so for example, here, don't stop here. Make sure you change the 8 to 9 because next to it is 9, a number which is 5 or larger, you have to do that. We're done with that. We are going to find the C. So let's choose again the same thing that we had, and then sine C over C. So we have that, sine C over C. So this part is sine 40 over 4. Sine C is sine 80 over C. Again, cross product means this is the product of these two divided by this. Again, you put it into a calculator. You go, since we went with two decimals, let's go with the same here. And the answer is 6.13. It's very straightforward. We got all the angles, all the sides. This is 630. Okay. We have all those sides. Now we have A equals 35 degrees, B equals 15 degrees, lowercase c is 5, and we are using the sine law to solve ASA, angle, side angle. So obviously the two angles are given. The first thing is to find the third one, the fastest and easiest. And by the way, if we want to write this just to make sure we know what we are dealing with here. So lowercase a, so this must be uppercase A. Lowercase b opposite that must be capital B here. It does have capital C here, so this is lowercase c. Okay, everybody? This is uppercase. So add them up, subtract from 180. And since this is 50, we get 130. So we have all the angles. Again, let's do either this one with this one or this one with this one. And since lowercase c is known, we are going to do this too. So this is 130 degrees. And so sine of A, 35 degrees, over lowercase a, sine of C, sine of 130 degrees, divided by 5. So that's what we get, everybody. Cross product. So the cross product means A is 5 times sine 35 over sine 130. Putting it into a calculator, will result in 3.7. So we replace the A with 3.74. Now we do the same thing, but this time with sine B over B equals sine C over C, and we plug in sine of 15 degrees over lowercase b, sine of 130 degrees over 5. Now cross product. B times sine 130 is 5 times sine 15. B must be the product of these two divided by sine 130. Putting it into a calculator, results in 1.69. Very straightforward, everybody. So we got all of them, everybody. Let's move on. So it's really not that bad, okay? Uh, just be careful if the drawing is given to you or if it's not, and you work on that accordingly. Now, side angle, SSA. Two sides and an angle opposite one of them. This is called the ambiguous case. So we may have a situation such as sine A is H over B, and A is smaller than H because H is B sine A. Okay, so if A is less than H, which is equal to B sine A, nothing works. No triangle. If H equals B sine A, if H is less than both sides, is less than A less than B. If H is less than both sides, okay, then we could have two triangles, the big one and this small one. Again, this one is one of them, okay? And the big one, that's why it's the ambiguous case. If A is larger than or equal to B, we get one triangle. If A is larger than or equal to B, because H is B sine A. And if A equals H equals B sine A, we get one. This one more specifically is a right triangle. So that's why it's called the ambiguous case. Let's look at examples of that, everybody. Using sine law to solve SSA triangle, solve the triangle when A is 3, B is 2, A is 40 degrees. So this is the given situation, everybody. Sine A over A equals sine B over B. And this is sine of 40 degrees. A is 3, sine of B, B is missing, and lowercase b is given as 2. So sine B is the product of these two, 2 sine 40 divided by 3. You put it into a calculator, you end up with 0.43. Let me explain what happens here. Whenever you get here, three things happen. Okay. One of them I'm going to discuss right now. I'll show you, and then the other two after that. So what is a B sine inverse of 0.43? So when you calculate sine inverse of 0.43, that gives you some angle, whatever. In this case, 25.4 degrees. Sine is equal to 0.43 from 0 to 2 pi in two quadrants, the first and the second quadrant. This acts as a reference arc. So you subtract this from 180. This would be the second possibility. Pay attention what happens here. So this is the first possibility. This is the second possibility for angle B. That's why we call it B1 and B2. Now, B1, A, and you can find the C and finish it off. How about B2? Add this to 40. If the sum is 180 or larger, this will not work. So you don't have to worry about that. Again, why is it not working? Because when you add with 140, you get 194.6. The sum of these two is larger than 180 degrees. That doesn't work. So you're done. There's only one, we finish it. However, if this plus this is less than 180, that gives you the second triangle. Is everybody with me? So right here, when you find the second one, immediately add these two. If it's less than 180, you have the second one. If it's larger than 180, you have only one. So this is so far discussing two types. When would it have no solution? Well, if this number is larger than 1, there is no solution. If this number is less than -1, there is no solution. And it happens, okay? That's what's called the ambiguous case. So we're going to continue with this part. So we have A equals 40, B equals 25.4, subtract the sum from 180, and the last angle is 114.6 degrees. Very straightforward, everybody. Now we use this one with this one. So it's 114.6 degrees. Use this too. Sine of, try to use what's given first, okay? Because that's more accurate. So sine of 40 over 3 is sine of 114.6 over lowercase c. The cross product means the c is the product of these two divided by sine 40. You put that into a calculator and it becomes 4.24. And now you can write all of them. So this side is 114.6. This is 25.4. This is 40. This is 2. This is 3. And now this one is 4.24. Now, example 4, We are continuing with SSA. This is case number 2. Solve the triangle A is 35 degrees, lowercase a is 6, and lowercase b is 8. Since we have A, B, and A, let's go with this one. Let's plug it. Sine of 35 degrees over 6 is sine of B, which is missing, over 8. Cross product. This 2 is equal to this 2. Therefore, sine B is 8 sine 35 divided by 6. You put that into a calculator and you write with a bunch of decimals again accordingly, always. If they don't, you really want to have quite a few decimals. Zero, if they don't add 0.7648. So that's sine of B. So what is B? Sine inverse of this angle. You put it into a calculator. Sine inverse of 0.7648 is almost 50 degrees, 49.9 degrees. Why we call it B1? Because remember, sine is positive in the first and the second quadrant, and this acts as a reference arc. Subtracted from 180, it gives you the other angle. So one angle is 49.9 degrees, one is 130.1 degrees. Obviously, this works because these two, the sum is less than 180. Does this work? Look, if we add them up, we get 165.1. Is that less than 180? Yes, that gives you quite a different triangle. So this gives us two different triangles. Okay. Therefore, we're dealing with a case like this. This is 35 degrees. This is 6. This is 8. And when we have this case, that means there is another triangle. And this is identical to this side, the smaller side, not the big one, the smaller side. And H. So we are going to work on this one as well as the big picture. Okay. So let's put in A, C, and then we're going to call this B1 and B2. Do you follow what I'm saying? Clearly, this is 130.1 degrees, right, class? This is B2. And this one is 49.9 degrees. Okay. So right here, add these two, subtract it from 180 to find the third angle. So 180 minus A minus B1. So 180 minus 35 minus 49.9, 95.1 degrees. This is the angle C, the big one. Okay. This one, entire C. Okay, everybody. This one. This is this. All right, and now we're going to use the same thing now, sine 35 over 6. Instead of sine B over 8, we are going to put sine C, which is sine of 95.1 over C. We're going to use this one to figure out the missing side. Okay, so this one, we use it again, and this part is the last part. Again, what is this C1? Product of these two is the same as product of these two. So C1 is the product of these two divided by sine 35. So C sub 1 is 6 times sine of 95.1 degrees over sine of 35 degrees. And at this point, you have to put it into a calculator and figure out some decimals. Okay, again, you want to be careful with the number of decimals always. 10.42. That means this side is 1042. That's the minimum. So the big one is solved. Now we are going to look at this small one. We are going to look at this one, everybody. Okay. We're going to look at this one. So we go here and we say, okay, well, we can find the angle, add these two, subtract it from 180. So 180 minus A minus B2 means 180 minus 35 minus 130.1. And the last angle, this little one, okay, 14.9. So you get an idea of which one I'm talking about, this one. This one is 14.9. Okay, 14.9. And sine 35, again, the same thing, sine 35 over 6, but this time sine of 14.9 divided by C2. And cross product means C2 is the product of these two divided by sine 35. Putting it into a calculator results in 2.69, which means what? This distance is 2.69. That's what it means. So let's write all of this here. Take a look. This large angle C is 95.1. We call it C sub 1. The smaller one is 14.9. This angle is 130.1 degrees. This is 49.9. This side, the large one is 1042. The smaller one is 2.69. Okay, I hope everybody's clear as to how we arrived at. So this is another one of cases, SSA, side angle, which is ambiguous, ended up giving us two answers. Okay, gave us two answers, everybody. Again, we are dealing with SSA, side angle. And we want to solve a triangle. A is 2, C is 1, capital C is 50 degrees, everybody. Sine A over A is sine C over C. So sine A over 2 equals sine 50 over 1. And sine A is the product of these two, but divided by 1 becomes the same thing. So sine A is 2 sine 50. When you put this into a calculator, It gives you a number larger than 1. Is larger than 1. No triangle, no solutions. So there is no solution, and it looks like that. A is 2, C is 1, too small to reach the other side when we choose the angle of 50 degrees. So no solutions. All right, let's go with applications. Solve applied problems. A surveyor takes two sightings of the peak. This is the peak of a mountain at a distance of 900 meters apart. So one sighting here, one sighting here, the distance of 900 meters apart on a direct line to the mountain. The observation are at angle of elevation 47 and 35 degrees, respectively. So over here, there's an angle of elevation of 47 degrees. Then it goes further away by 900 meters, and it has definitely a different angle of elevation, and that's smaller, 35 degrees, respectively. If the transit, here's the piece that they use to come up with the angle and so forth. The transit is 2 meters high, so this is 2 meters high. What is the height of the mountain? We want to find the height of the mountain. So what are we talking about? Let's look at the setting, everybody. So this is 2 meters high, angle of elevation 35 degrees here, angle of elevation 47 degrees here, and this distance is 900 meters. This is the B side of the triangle, and this is 2 meters. H is B plus 2. So let's call this B, let's call this D, let's call this C. H is what we are interested in, is the sum of a B and 2 meters. As long as we find B, we are in good shape. So let's find B. If you look at this triangle, we have this angle, 35 degrees. We don't have this angle, but I hope you recognize that this one, everybody, is 180 degrees, which means C plus, this is a straight angle. C plus 47 must be 180. Therefore, C is 180 minus 47, or 133 degrees. So C is 130 degrees. Let me erase my work here. So this is 133 degrees. So if this is 35, this is 133, this must be what? Subtract the sum from 180. So in this triangle, ABD, they have put the A here, okay? ABD, we are talking about this one, everybody. In this case, all interior angles must add up to 180. So A and C and B must add up. So let's see what we get. So 133 plus 35 must be subtracted from C. So A plus C plus 35 is 180. And C, we know C is 133. So these two add up to 168, subtracted from 180, and you get 12 degrees. So A is 12 degrees, everybody. So we have this angle at 12 degrees. Why are we interested in that? Well, we want to find this C. And now we have everything because we have one side and we have all the angles. We can find all the sides. So let's find C. Using the sine law. Sine of 12 degrees over the opposite side, 900, is sine of C, sine of 133 degrees over the lowercase c, the opposite side that is missing. So in this triangle, we have all the angles. We have one side. We can find the other two sides. We are interested in C. Uh, just for the sake of argument, if you put sine of 35 against this side, you can find this side. Whether you find this side or this side doesn't matter. You are in business. You can finish the job in no time. We need one of those sides. That's all. So the product of these two is the same as product of these two. Therefore, C is 900 sine 133 divided by sine of 12. You put it into a calculator. It results in 3,165.86, and the units that you have here in meters. And again, the number of decimals, perhaps this is a whole number, they go with one decimal, but I went with two decimals, you decide. Normally they ask you for the number of decimals. Now, again, as I said, as long as we have one of these sides, it doesn't matter which one. So now that we have this side, C, in this triangle, A, B, C, sine of 35 is the opposite B over the hypotenuse C. And C, we found it to be 3,165.86. And therefore, B is the product of these two numbers, sine 35 times C, which is this number. So B is the product of sine of 35 and this number. And you put it into a calculator, gives you 1,815.86 meters, which means the height is the same thing plus 2. The same thing plus 2. And it's an approximation class. I changed this to a whole number because that's normally what they do. And it's 1,818 meters. You can keep it with decimals or otherwise. Just pay attention to the way they want you to report it. Okay? Reporting makes a huge difference. The way you report it must be consistent with what they ask you to do. Okay? All right, we are ready to move on. Coast Guard Station Zulu is located 120 miles due west of Station X-ray. So we have Zulu, we have X-ray, and they have a distance of 120 miles. A ship at sea sends an SOS, save our ship, call that is received by each station. So sends it and both of them receive it. The call to Station Zulu indicates that the location of the ship is 40 degrees east of north, bearing north 40 degrees east. So that's the bearing. And that means if this is 40, they must add up to 90. That means this is 50 degrees. The call to X-ray indicates that the ship is 30 degrees west of north, bearing north 30 degrees west. So for this one, north 30 degrees west. So because they must add up to 90, this must be 60. That's what's given. How far is each station from the ship? So in other words, we want this distance B, we want this distance A, this one is given, two angles is given, so we use the sine law, and the very first thing we do, we say, okay, this is 50, this is 60, so class C must be sum of those two subtracted from 180. So C is 180 minus, when we add these two is 110 subtracted from 180, and C becomes 70 degrees. That's the first thing. C becomes 70 degrees. And now we use the sine law. Sine of 50 over A equals sine of 60 over B equals sine of 70 over C, which is 120. So this is known. If you use it with this one, you find A. If you use it with this one, you find B. Since we want A, so I'm not gonna, so you use this too, okay, class? That means A is 120 times sine of 50 divided by sine of 70. And that A is the distance to X-ray. So for X-ray, A is 120 sine of 50 divided by sine of 70. You use a calculator, and it gives you 97.82. And the units, class, the same units, miles. Now, to find the distance for Zulu, we have to find B. Let me erase my work again. And now just these two. So B is the product of these two, 120 times sine 60 this time, divided by sine 70, right? Because the product of these two is the product of these two, right? Cross product, 120 times sine 60 over sine of 70. Sine of 60 is square root of 3 over 2, but nevertheless, you put that into a calculator because this is also an arc which is not common. So 110.59 miles. So A is almost 98, and B it's close to 111 miles. If a helicopter capable of flying 200 miles per hour is dispatched from the nearest station to the ship, how long will it take to reach the ship? Obviously, we can go from here or here, and we showed that this is a shorter distance, so that means definitely we go from here. And remember, this D is equal to RT, and T equals distance over R. Distance, we are going to use A. And A is 97.82. The rate or speed on the average is 200 miles per hour. And you get 0.489 hours. And normally we don't close to 0.5 hours. Normally we don't repeat it, we don't report it like that. How do you go to minutes? If you multiply this by 60, gives you 29.35 minutes, although this we knew that this is close to half an hour, so close to 30 minutes, 29.35 minutes. Very straightforward, everybody. The highest bridge in the world is the bridge over the Royal Gorge of the Arkansas River in Colorado, sidings to the same point at water level. Directly under the bridge is 880, are taken from each side of the 880-foot-long bridge. As indicated in the figure, how high is the bridge? So here's 880 feet. This angle is 69.2 degrees given to us. This angle is 65.5 degrees. These are from the siding. And so we want to see that what's going on here. So we want to find H. Let's call this distance X, everybody. Let's just call it X. Just give it a number. Now let's do this drawing here so it becomes clear. So we are going to look at this triangle only. And we're going to call it ABC. This distance is 880 feet. There's nothing brand new. This distance is H. This distance, we called it X. This angle is 69.2 degrees. This one is 65 degrees. But ABC makes it easy to work with. This one, let's call it D. Okay. So ACD, you're looking at this one, everybody. The sine of 69.2 is H over X. And H is the product of these two. And all we have to do, find X, we are home free. Now let's go to the big one. ABC. This is 65.5. This is 69.2. So what is this one? Add them up, subtract from 180. So we get the last angle C is the sum of these two numbers subtracted from 180, resulting in 45.3 degrees. And now we go with the sine law. And we want X. Remember, we have, as long as we have the angles on one side, we can find the X using the sine law. So X is opposite 65. If we are looking at the big one, okay? The entire, not half, the entire triangle. So sine of 65.5 degrees over X. Now we want to use this number. So sine of this one, C, 45.3 degrees over 880. So this is 45.3 degrees. This is the sine law. X becomes the product of these two divided by this. So X is 880 sine of 65.5 degrees divided by sine of 45.3 degrees. You put it into a calculator. Make sure your calculator is in the It's run in radian, it's in degree mode. And x is 1,126.57 feet. So replace the x, because we were looking for x here, with this number. Replace the x with this number. So h is 1,126.57 times sine of 69.2 degrees. Putting it into a calculator results in 1,053.15 feet. So the height is 1,053.15 feet. Very straightforward, everybody. Application. Example number 9. The navigator of a ship at sea spots two lighthouses that she knows to be 3 miles apart. So we have a distance of 3 miles between these 2 points, P and Q. She determines that the angles formed between 2 lines of sight, observations of the lighthouses, and the line from the ship directly to shore are 15 and 35 degrees. So from here, okay, if we compare it to if you drop a perpendicular, this is 15 degrees, this is 35 degrees. So this is the given information. And the distance PQ is 3 miles. How far is the ship from point B, lighthouse P, and from point Q, lighthouse located at Q? We want to find this. And to find this, again, let's just draw the same thing here, everybody, and observe as to what's happening. So here's, again, point P, point Q, and the ship, we're going to call it R. This angle is 15 degrees. This angle is 35 degrees. And this distance PQ is 3 miles. So that's making sure that we know what's going on. And this distance is D. And so what we want to find is for P, we want to find PR. For Q, we want to find QR. So that's what we want to find. So we are going to find all the angles. So pay attention, because it's going to go very nice, very easy. So we are going to look at each. Okay, let's just look at this one. This small, the bottom one. And remember, this is 90 degrees. Class, we've dropped the perpendicular. This is 90 degrees. This is 35 degrees. So they must add up to 90 degrees. What would this be? 90 minus 35. 90 minus 35. That makes it 55. Now this one, let me use a different color on that. Let me use, okay. So maybe I write this. So this one is 90 minus 35. This one is 90 minus 15, 75 degrees. What about angle R? What about this angle? Just add these two. This angle 15 plus 35, 50 degrees. So angle R is 50 degrees. So I hope everybody's comfortable with what we just did. Let's quickly recap because I want to make sure you're comfortable with that. So what we are saying is, this is 15, this is 35. So this one is 90 minus 15 and it's 75. This one is 90 minus 35 and it's 55. And this one adds up 15 and 35. This angle 15 and 35, 50 degrees. So first we want to make sure, and I'm going to erase my work so you can see clearly. Again, 35 means this is 55, 15 means this is 75, 15 and 35 must be added to give us angle. Okay, now we're going to go with this and we are going to look at the big picture. And we have all the angles and we have one side PQ. Okay, so we are going to use this and use this. So sine of this, sine of 50 over 3 miles is sine of 55 over the missing PR. Okay, this is for this distance PR. And so what is PR? The product of these two, 3 times sine 55 divided by sine of 50. And put it into a calculator, you get 3.21 miles. Quick recap. These two angles are given. We find every other angle, including the sum of these two. And in the big picture, one side is needed, it's given. We have all the angles. Set sine law gives us the other sides. Now, what are we looking for this side? QR. So we're going to use again sine of 50 over 3. We're going to use the same thing, sine of 50 over 3. This time, sine of 75 over QR, sine of 75 over QR, which means QR or RQ, whatever, is the product of these two, 373 times sine of 75 divided by sine of 50. And put it into a calculator, you get 3.78 miles. Obviously, it shows that this is large. And it should be because it's opposite and larger. And this angle is larger than this, so this distance must be. Last part says, how far is the ship from the shore? That means this distance, class D. So we draw one of these, half of them. Let's say the top one or the bottom one, makes no difference. If you draw this top one, let's say, okay. This is the distance D, this is P, this is R. This angle is 75 degrees, and this distance we showed PR to be 3.21 miles. This is just the given. I'm just writing it so it becomes clear. Different ways of finding the, I'm going to go with the sine law because it's the section of the sine law, and I'll show you a different way in a moment. So if you want to go with the sine law, okay, this is obviously 90 degrees. So sine of 90 to 3.21 is sine of 75 to D, right? Sine of 90 3.21 is sine of 75 to D. And D is the product of these two numbers, 3.21 times sine 75 over sine 90. You put it into a calculator and you get 3.1 miles, 3.10, okay? Because we wanted to go with 2 decimals. The next one doesn't change this. However, you don't have to do this. I did it on purpose because we are dealing with the sine law as far as the section is concerned, okay? The fastest and easiest way would be sine of 75 is the opposite D over the hypotenuse PR, which is 3.21. So sine of 75 is the opposite D over the hypotenuse, 3.21. So D is the product of these two, which gives you the same answer. And again, we wouldn't use the sine law. This would be easier this way.